the original ones, the first day we did the quotient, so those were 0 over 0 or infinity over infinity, and our strategy was just go straight into L'Hopital. Yesterday we did the product, 0 times infinity, and the difference, infinity minus infinity. And our strategies for these were to write as a fraction, and then you can do L'Hopital. Today, we are talking about the powers. So there are 3 of them. 0 to the 0, infinity to the 0, and 1 to the infinity. Our entire goal is to somehow get a quotient in here so that we can do L'Hopital's rule. Okay, so essentially on all of these, we're trying to write them so it's 0 over 0 or infinity over infinity. To do that, what we will have to do is add a natural log to write it as a fraction. Then we can do L'Hopital's. However, we can't change the original problem. So if you add a natural log, okay, so if I start with, let's just do basic. If I start with an x, if I add a natural log to that, what do I need to put to cancel my natural log? What's the opposite of a natural log? The inverse. It's e. So if I did e to the natural log of x, the e and the natural log cancel and it just equals x. So what we'll do is we'll first add the natural log, because then we can use some properties of logs to get a fraction. But once we evaluate that, then for the final answer, it will be e to whatever answer we got. So if we did the L'Hopital's and we got 5, then our final answer is e to the 5th. Because we added the natural log, we have to cancel that out. So this we have to remember 2 things. If you add the natural log, then your final answer will be e to whatever power you get. Alright, so we are just going to work some examples with this today. Okay, so the limit as x approaches 0 from the right of 1 plus sine of 4x to the cotangent x power. So if I am looking at this, if I plug in a 0, sine of 0 is 0, 1 plus 0 is 1, cotangent of 0, cotangent is undefined at 0, so we have an asymptote, so it's approaching infinity. So this is a 1 to the infinity power. That is an indeterminate form. With these indeterminate powers, what we are going to do first is add a natural log. And since I add the natural log, I know at the very end my answer is going to be e to some power, because I have to cancel that natural log back out. The reason the natural log is so nice is properties of logs. What happens to this exponent? It can drop down in front. So I could just move this down here. And now this is an indeterminate product. And those products, we tried to write them as a fraction, didn't we? So would it be easier to move a cotangent or a natural log to the bottom? Cotangent, definitely. What would that turn into when I put it on the bottom? The reciprocal of cotangent would be tangent. So by adding that log, the exponent will come down, and then you can easily turn into a quotient. Let's do a quick check here. If I plug in 0, I get the natural log of 1, which is 0. Tangent of 0 is 0. So it is currently of the form 0 over 0, which tells me I need to do L'Hopital. Okay. Derivative of a log is 1 over the argument. So we have to do a chain rule. So times the derivative of the inside. So derivative of 1 is 0, derivative of sine is cosine 4x, times derivative of 4x is 4. Over derivative of tangent is secant squared x. Okay, we might have to clean this up some. Let's see. If we plugged in 0, sine of 0 is 0, so we get 1 over 1 times 4. Cosine of 0 is 1. So if cosine of 0 is 1, secant is also 1. So we can evaluate this. I just get 1 times 4 divided by 1, which is 4. So my final answer is not 4, it would be e to the 4th power. Okay. Any questions on that one? Why don't you guys see if you can start this one? It's not super ugly. This is currently 0 to the 0, we all agreed there. And so you guys added the natural log. And when you add that natural log, then this x would come down. So we know our answer will be e to a power. If you look at this right now, if you just plug in, you have 0 times the natural log of 0 is undefined. It's got a vertical asymptote there. So it is still an indeterminate form. Then, if I want to move something to the bottom, definitely easier to move that x. You can write it as 1 over x or x to the negative 1, whatever you're most comfortable with. So now, as we're approaching 0, really I should have from the right because you can only do it one way here. The top is going to negative infinity, the bottom is going to infinity. So is this, I'm going to switch that, make that 0 from the right because this only works from one way. So is this still indeterminate form? But now we can do L'Hopital. So the derivative of natural log is 1 over x. The bottom, this is negative x to the negative 2. If you clean that up, 1 over x. Negative x to the negative 2 is negative 1 over x squared. If you flip and multiply, you just get the limit, x approaches 0 from the right, of negative x. So we can certainly plug in and you get 0. So our answer is e to the 0 power, which is 1. Anything to the 0 power is 1. Are we okay with that one? done examples 10, 11, and 12, so we are ready for 13. Yes, sir. Yeah.
So anything to the 0 power is 1, right?
Mm-hmm.
So why is infinity the 0 power?
Okay, so technically a number to the 0 power is 1, but 0 to the 0 is considered undefined, and infinity to the 0 is kind of the same thing. They're just saying it doesn't work because you're approaching 0, you're not at 0 exactly. So if you have a really big number to even like a 0.5 power, you're going to get an actual numerical answer. So it could approach a number other than 0, or other than 1, excuse me. Okay, let's look at example 13. So if we plug in here, cosine of 0 is 1. 1 over 0 is undefined. If you think 1 over x squared looks like this, so it's going to infinity as you approach 0. So this is 1 to the infinity, which is an indeterminate form, which means we have to do the log. So we'll add the natural log of cosine x. Do you guys care if I go ahead and write my 1 over x squared out in front? So since I have the natural log, I know my answer will be e to a power. I can easily write this one as a quotient. Be the natural log of cosine x over x squared. So now, cosine of 0 is 1, natural log of 1 is 0 over 0. So that tells me we can do L'Hopital. Alright, derivative of a natural log is 1 over the argument, so 1 over the cosine x.
May I have everyone's attention, please? The following.
Back to our problem. We got to enjoy the weather. So, derivative of natural log is 1 over the argument times the derivative of the inside, because we're doing chain rule. So, derivative of cosine is negative sine over the derivative of x squared would be a 2x. Okay, as far as cleaning this up, on the top we have sine over cosine, which is tangent. Okay, so this is still 0 over 0, isn't it? What does that tell me? L'Hopital again. So derivative of negative tangent would be a negative secant squared over derivative of x would just be a 1. So secant of 0 is 1, so we have negative 1 over 1, which is negative 1. So our final answer is E. I dropped a 2, didn't I? That should be a 2x right there, so this should be a 2. So this should be negative 1/2. So our final answer is e to the negative 1/2. Is that okay? One more. Limit as x approaches 0 from the right of x tangent x. Alright, so if we look at this one currently, it is 0 to the, what is tangent of 0? 0 to 0, so it's indeterminate power, which means we add our log. When we do that, can I go ahead and just drop down that tangent? Okay, we need to write this as a quotient. So it would probably be easiest to move the tangent to the bottom. What would that become then? Cotangent. Okay, as you approach 0 from the right, your natural log graph looks like this. So as you approach 0 from the right, it's going to negative infinity. Cotangent is approaching infinity. You've got an asymptote there. So this is an indeterminate. So we can do L'Hopital's. Okay. So the derivative of natural log 1 over x over, what is the derivative of cotangent? Good. Alright, I want to clean this up some. Negative cosecant squared is like negative 1 over sine squared. So if you flip and multiply, you get a negative sine squared x over x. So what now? Still 0 over 0, so we have to do L'Hopital's again. Okay, so the exponent comes down, so that'd be negative 2, inside stays the same. Subtract 1 from the power, so it's just to the first, times the derivative of the inside, derivative of sine is cosine. Over on the bottom, derivative of x is just a 1. So if we plug in, we have negative 2, sine of 0 is 0, cosine of 0 is 1, and we get 0. Is that my final answer? No, we added a natural log, so it has to be e to that power, and e to the 0 is 1. Okay, so we have some time. I want to give you guys a chance to ask questions if you needed to. So yesterday's problem, there is an answer key, of course, if you need to check it. If you need to ask about anything, you can. And then we are adding to that. Again, I'm giving you odds, but you better have work. If all you have is the answer, you're not going to get credit.